Well, as Dave has already said, my name is Darren Swan. I'm a software engineer here in Austin. I dabble in hardware enough to be dangerous, and actually, given some of my projects I'm going to mention later, very dangerous. Turns out mains power on Raspberry Pis, got to be a little careful with that. Just FYI. Tonight we're going to set up a Raspberry Pi from scratch. We're going to set it up headless without the need to pre-configure the network connections, which is something that I don't know how many times I've had people complain about the fact that trying to set up that WPA supplicant file in the root directory on a Raspberry Pi to try to get the Wi-Fi set up right off the bat has been one of the biggest problems in getting a Raspberry Pi set up headless. Unless you're running the Pis that actually have the Ethernet adapters, plugging into Ethernet, simple. Just drop an SSH file on there, it automatically configures SSH to turn on, SSH into it, you're good to go. But if you're in an area where you have to use the Wi-Fi, this is an alternative route that will definitely make things a lot simpler for you. So without further ado, let's go ahead and get started actually flashing our Pi. I like to use an application called Balena Etcher.
Is that the same one you used to use? No, that was PieBaker, wasn't it?
PieBaker is one that I've used in the past. And PieBaker is actually a really nice tool because you get like a snap style interface. Kind of like the, what is it, Scratch programming, Snap, Scratch? It's a programming language that they're teaching in schools nowadays, and it's got a very, Scratch? It's got a very Lego-like interface to it where you just snap components together. PieBaker follows along that same lines and tries to make things simple for you. However, we ran into a few hiccups that I've actually boiled down to. It was because we weren't updating at the time we were trying to install. But for the sake of this, I've already downloaded from the Raspberry Pi website. You can download the image for Raspbian Buster, which is the most recent copy. If you wanted to download it for yourself, you would go to Raspberry. Oh, there it goes. First result. RaspberryPi.org. And they have this nice downloads button. And thankfully, Capital Factory is awesome internet. Click on Raspbian here, and then this gives us all of our various versions. You could go the noobs route if you wanted to, because that gives you the ability to install multiple operating systems, and you just pick which one you want to run. But for the sake of this, I'm going to keep it simple, and we're only going to run with the Raspbian Buster Lite, because one, that's the smallest of the images. I'm using a 16 gigabyte SD card, so the size of the image isn't the important factor here. It's just the fact that there's not a lot of extra software installed that I would have to then configure and combat with, especially later on if I decide to secure the device, more so than what I'm going to do as part of the initial setup. But I have actually already downloaded it. So, and I have it right here. It's open. So I've selected my image. It automatically picked my thumb drive or my SD card here, which I have right here. Let's continue, and let's go ahead and flash it. Yes, I know. While that is flashing, I'll go over just a few more things that we're going to cover today. One of the thing that really makes being able to set up headless without the need to configure the networking or the Wi-Fi right up front is this thing called a USB to TTL or USB to UART adapter. It's using actually a ProLiant chip, so be very, very careful. There are...
I don't mean for you to stop, but where does FTDI fit into that equation?
Good question. I have actually not directly interfaced with FTDI,
Okay.
so I'm not actually certain.
All right.
But going back to my previous train of thought, with the ProLiant chips, there are a rash of counterfeit chips that have been circulated. I've actually gotten a hold of a few just off eBay. In fact, I have one of them in my box over here. Right there. It's physically, or functionally, it's the same as what I have right here, but the difference is that this one was counterfeit. And so the folks at Proliant have actually contacted the major operating system vendors, and they actually have a driver that blocks the use of this chip. So if you're in Windows and you plug this in, it'll recognize it as a Proliant chip, but it'll recognize it as one that's no longer capable of being used. So anybody who actually has the real version of this chip has also been affected by that. So just be fair warned. This particular cable, I think I bought mine on Amazon for about $9. It's equivalently priced if you go through adafruit.com. But this one, I got 2 of these and they cost me 50 cents. So I was hoping this would actually be just a really cheap alternative. Turns out it's really cheap, but not really an alternative.
Was that with the 6 weeks delivery?
Yes. Actually, no, I got it in like 2 weeks, but this was back before the trade wars with China started, because these were actually shipped to me from China. And I can pass this around. I mean, it doesn't do me any good if it ends up missing anyway, but if anybody just wants to look at these, you want to look at it? Here you go. Sure. So yeah, just be careful when it comes to where you source your components, because if you run into a counterfeit component, you know, things could just stop working and you have no idea why. I spent probably at least 2 or 3 hours trying to troubleshoot that before realizing and stumbling across the documentation that said that there is a counterfeit version of that chip. Yeah. And so they've locked all of that version of the chip out and released an updated version, which is what's here, in order to combat that. Okay, there's a wire there. And I didn't cover where the Balena Etcher application comes from, but if you just do a search for Etcher online, E-T-C-H-E-R, which, since I have a second, I'll just go ahead and bring that up. Balena Etcher. So it's balena.io/etcher. This is probably the simplest way to flash a Raspberry Pi by far. Simply because, I mean, you guys just watched me walk through the entire process. It said it failed. Let's see if it continued to work, because sometimes these will fail the checksum, but they actually are still good. This just means it failed the verification process. So let's go ahead and eject. Oh, it's already ejected. Awesome. All right. And before I get ahead of myself, there is a minor change we do need to make on the SD card itself in order to work with the TTL cable. You can go away. Go away. I don't want my pictures. All right. So here in the boot sector, which is the only FAT32 sector on the SD card, which is the only part that Windows can actually read, we have this config.txt file. Now, keep in mind, this file, it has Unix file endings on it. So if you try to open it in Notepad, let's see, open with Notepad.
It'll look funny.
Well, actually, with the new versions of Notepad, it looks just fine now.
Is it
Windows
the whole?
has finally released, at least in Notepad, the ability to be compliant with Unix file endings in addition to the way Windows has done it in the past.
But will it tell you if you're using, if the file is Unix file endings or not?
Nope.
File
So you
endings
just
or
watched me open it.
line endings?
Yeah.
Well, the line endings is the Unix line endings.
Yeah.
Yeah, because I mean, on my editor, it'll tell you when you've opened a file whether or not it's, you know, Windows line endings or actually DOS or
Yeah, or Unix.
Unix or Mac.
Okay. Well, this line right here, which here, it says DT overlay equals LIRC-RPI. This is the line we need to change. So one, we need to remove the comment from it. and then we're going to be changing this. What we're changing here is what's called the device tree overlay. And what the device tree overlay does is pre-configures the firmware on the device to tell the operating system what devices are available and how they're configured. And so what we're going to do is with this nice overlays folder, which has a lot of different potential configurations, we're going to look for this Pi 3, and we're going to do Pi 3 mini UART Bluetooth. And the name does have to match exactly. So what I typically do is just copy it. We'll go over here to config.txt, and we'll paste it. Let's go ahead and save, and then, oh, come on, move over. Move over. Let's close it. All right, now we should be able to go ahead and eject the drive. Okay. And I'm going to use an application called MOBA XTerm. This is a really handy X terminal application that will allow you to do like X forwarding on a Linux over SSH, as well as gives you a bash terminal on Windows without having to rely on the Windows subsystem for Linux to get it, or using something like PuTTY, which is not the most user-friendly of applications. PuTTY is awesome. PuTTY is great, but they could do a little bit to work on their user interface. So if it wasn't for that, I would actually use PuTTY for this, because most of the documentation online you see nowadays tells you just to use PuTTY. But MOBA XTerm is free, unless you decide you want the enterprise, which just unlocks the ability to do additional user sessions and whatnot, at which point I think that's $50 or something like that. It's not expensive. But I'm using the free version here. What I'm going to do is we're going to start a new session. We're going to go do a serial session. And the Raspberry Pi, by default, uses the 115200 baud rate. And then here's our prolific serial. It shows up as a serial device. And that's what the TTL is. So let's go ahead and click OK. And here we go, we have our serial console. And now this is actually the really cool part, because when you're connecting over SSH headless, you won't see this information. But connecting this way, just apply power to the Pi, and just wait a second. We actually have the initial boot information from the Pi. However, there we go. It's taking its sweet time tonight. There. And this is all coming straight from the Pi via the serial connection. And here in a second, we'll be able to actually do just like we would over SSH, and that's run raspi config and do everything we would any other, setting up the Raspberry Pi any other way. We just had to make that one tweak in that one file, and then hook up the serial adapter here, the TTL cable. Once this is done, what we're going to do is we're going to actually configure for SSH and then attempt to SSH into it so we don't need the cable anymore. And also so that way we can use SFTP to be able to copy files over to the Pi from my laptop here. And yeah, see, now we have Raspberry Pi login. So, username Pi, password Raspberry. Did I type it wrong? Yes, I did.
Mm-hmm.
There we go. Sudo raspi config. Ta-da! This should look very familiar to anybody who's set up a headless Raspberry Pi before. And now, we are not actually running this over a network still. We're still on the serial connection. So let's go ahead and change the password for the current user. DEMO123. Wait, don't remember that. There we go. Network options. Actually, I'm not sure. I'll figure this out in just a second. Host name, let's leave it Raspberry. It's going to be Raspberry Pi. I think it's Raspberry Pi or something along those lines. But the part we actually need to look at is, let's go to localization options. Let's change our locale. All right, this is the one that doesn't let me skip. All right, we don't want ENGB because we are not in Great Britain. Let's go with EN-US, and let's go with the UTF-8. All right, this is going to take just a second to run. Changing your locale up front and changing your keyboard configuration and whatnot is actually quite important because of the way things are handled in the operating system underlying. And this is a Linux operating system. And so you could actually run into problems, especially if you don't configure your keyboard correctly, or if you configure the keyboard for the wrong locale, then you can actually end up with a keyboard that you press the Q key, you get a different letter.
That drove me nuts.
Well, maybe next time you'll remember to change your locale.
I did. Haven't done it since.
Let's go ahead and update our time zone. Let's see. America, and we are Chicago. Keyboard layout. Wait. That's new. Okay. Well, let's keep going and hope nothing changes or nothing breaks. Wi-Fi Country. And also, if you don't set your Wi-Fi Country correctly, which when you go through the settings for setting up your Wi-Fi, it will actually have you configure the Wi-Fi country. But if you don't set your Wi-Fi country correctly, you may or may not be able to connect to your Wi-Fi router depending on what channels are available for your Wi-Fi in whatever country that you picked. For instance, I believe Japan actually is identical to the United States with the addition of 1 or 2 additional channels that are not allowed to be used in the United States. So in theory, if you don't really care about respecting the FCC's regulations, you could actually set to Japan and use those additional channels and have very little interference from your neighbors. However, I make no claims as to guarding you from the FCC if they were to find out. So,
Doesn't the FCC work for us?
do what?
Doesn't the FCC work for us anyway?
And
They would have to be within range.
yeah, they would have to be within range.
They work for us by blocking you.
Yeah.
All right. Let's go on to interfacing
Whoever the
options.
offender is.
Yeah.
And let's turn SSH on. Yes. SSH is enabled. Okay. Alrighty, let's go ahead and let me grab my phone real quick actually. I forgot I am currently on the guest Wi-Fi here at Capital Factory, which does actually enforce client isolation. So I will not actually be able to remote into my Pi straight from my laptop because I'm on the guest Wi-Fi. However,
Dave, can't you get on the regular Wi-Fi?
I can too, I just don't remember the password.
Yeah, I never use it, any of them, so I don't know.
Would she have it out front?
She probably does. If you wanted to go get that for me or make Dave do it.
I could turn my hotspot on if that would
Well,
help.
that's exactly what I'm doing.
Oh,
What, you want me to ask her?
No, I got it. I just used my hotspot.
Okay.
Okay, let's disconnect and let's connect to. Yep, already connecting. Okay. Let's come over here. Just keep in mind when you're over here, it doesn't matter what you click on. All it does is highlight. So like I can click select all day long. And all it's going to do is highlight, because this isn't actually an interactive in terms of mouse interactions. It's only keyboard interactions, and that's it. So let's go ahead and go to network options. Let's change the Wi-Fi. And what did I set my SSID to? It is G6 underscore D6. And then what is my password on here?
And what's your password?
Asterisk, 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 asterisk. Okay. Let's go ahead and tell it to update and see if it can find anything. Yeah, and it says we're already up to date. Okay, and then let's go ahead and do, actually, one more thing real quick. Advanced options, expand file system. All right. And finish. And yes. All right, the other really neat thing is that using the serial over the UART, we not only get the startup messages, we also get the shutdown messages that happen after the SSH connection has actually been ended. The process that hosts the SSH connection gets killed fairly early on in the shutdown process. But here we actually get to see the entire shutdown process. So if you need to debug something at a much, much lower level than what would typically be available, this gives you that particular capability. So like now we've completely rebooted and we're back to the Raspberry login. However, I want to try, let's flip over here to the terminal. Come on. Fine, I'll use the mouse. Open up a nice terminal here. Let's do SSH pi at Raspberry Pi. See, will it find that? Nope. Okay. So instead, let's actually use the Raspberry Pi's IP address 192.168.43.199. I'm aware of this because since it's connected to my phone's hotspot, I can actually look up the IP address directly here. Otherwise, I could flip back over here. Pi. I have config. And look, see, 192.168.43.99. Flip over here. Enter. Yeah, keep connecting. Password. Hey, look, I am now SSH'd into my Raspberry Pi. And, you know, it only took 49 minutes. Give or take one of Dave's speeches.
I have problems with using the name instead of the IP address. And I had to set up a DNS server, but it didn't always work. Am I just doing something wrong? Like for Raspberry Pi.local. So if you're trying to know...
Well, Raspberry Pi.local will only work if you're using the zero-based configuration, which is sometimes called Bonjour from the Apple people.
Okay.
However, if you have a DNS server set up, the Raspberry Pi will automatically register itself as the name Raspberry Pi,
Okay.
Unless you change the host name in Raspberry config. If you have a proper DNS server set up, anytime you do the like at Raspberry Pi for the SSH, the Pi at Raspberry Pi,
Yep.
it'll try to resolve that using your local DNS server, so long as your computer is configured to look there first. If your computer is actually looking at an external DNS server, it's not going to see that.
Okay.
Some wireless routers give you some DNS capabilities locally, so that way you can hit other computers on your local network by name. But I found that to be relatively hit or miss. The longer a computer is active on the network, the more likely it is that the name will work. But if the computer frequently disconnects and reconnects, it may or may not work. So in the case of my home network, I can hit my desktop PC by name almost every time because it's hardwired and I never turn the thing off. But my laptop, I can almost never hit it by name because it's constantly home, away, home again, away again, So if you go into your Windows connection, or I'm assuming you're running Windows.
I'm running, I'm having trouble when I'm running Windows, not Linux, yeah.
Okay. You just need to make sure that your local DNS is pointing to the DNS server that you've set up.
Okay.
Otherwise, if it's pointing to anything else, it won't see the entries for the Raspberry Pi.
Okay.
Is your machine on the same subnet?
On
'Cause
the
they don't
same
need-
subnet.
Yeah, because you can always look on the router to see what DHCP it got. It should resolve the name.
Well, it happened like at the meeting last week when I wasn't on, like I couldn't get to them was when it first happened. And then I was running ZenMap and it wasn't even like kind of resolving it, so, but I bet I don't have it 0.1%.
Yeah. Do you have it set up with a static IP?
I could have set it up with a static IP. In this particular case, my phone is operating as DHCP,
Oh.
so
'Cause
my
I was-
phone just assigned the IP address automatically.
Yeah, because I was thinking you could always just stick something in the host file,
Yeah.
quick and dirty, you know.
Yeah. Just don't forget it.
Yeah. Actually, you could also go into your wireless into your router
Yeah.
and set a static IP that way as well.
Yeah.
So that way, the MAC address for your Raspberry Pi is automatically associated, and anytime regardless of what host name you configured for your Pi, it'll have a static IP, and then you don't have to remember what the name is. Just remember that one static IP,
Yeah.
and it will be the only device to get that IP from your router.
Okay.
So okay.
Thank you, guys.
Alright. And the very first thing I almost always do once I get my Pi configured and get logged in is update it. If I can type. Alright. However, at this point, we actually no longer need our connection over here. So I'm actually going to go ahead and disconnect it.
Which connection? The serial?
The serial.
This is the serial connection, yes.
Okay.
So let's disconnect that, plug it.
And then I know those USB serial connectors we use a lot in ham radio.
Mhm.
Boy, I tell you, they can be a handful sometimes.
Yeah, luckily with this one is plug and play with Windows OS 10 and Linux. The drivers should already be available, assuming you're running the most common distros of Linux. And I have had no problems other than ones I've created for myself, such as forgetting which order to put the white and the green wires on. Now, one interesting fact is this particular cable actually has a fourth wire on it, which is a red wire. That is actually a 5-volt line that is running off the USB port on your PC. So if your computer has powerful enough USB ports, which most laptops probably won't unless they're USB 3 enabled, you could run a Pi 0 straight from this 5-volt pin. And that way you don't actually have to have an external power source. You can power and configure the Pi straight from this one cable. However, once you detach this cable, you'll still need that external power source to turn your Pi back on. And you also need to remember to shut down your Pi before unplugging. Always remember to shut down your Pi. Because it's running off of a micro SD card, you never know if it's going to corrupt that card.
And that line is good up to, what, about 500 milliamps?
500 milliamps is the USB 2 standard. I believe USB 3 will actually go up to either 900 milliamps or a full amp.
From a laptop.
Assuming the laptop actually gives you that full power. In most cases, I've actually had no problems with my laptop here, which is a USB 3, I believe it's 3.1 actually, to be able to power my Pi Zeros when configuring it. I've actually had more problems finding header pins for my Pi Zeros to plug into than trying to get it to power from the Pi.
All right.
Back in the day, we
There are
had
multiple modes,
Yeah.
so if you're doing data transfer, it's limited to 900 milliamps,
I believe
or 3.0 at least.
believe with my particular laptop, it's actually capable of doing phone charging off the laptop itself, which I believe actually gives a full 2.4 amps.
Yeah.
But that
Power
might just be a
delivery mode.
unique feature of my laptop and not something that's part of the USB standard.
Power
Alright.
delivery mode, standard.
Is it standard?
Yeah.
Okay. You can go away now. I don't need you. All right. Now that we are up to date, let's flip over to the actual Microsoft side of things and get set up with our get our application set up. Now that the Pi is ready to go. All right. It's tiny. So minimize you. We will be using .NET Core. And so for those of you who are not familiar with .NET Core is the open source cousin, little brother, whatever you want to refer to it as, from the .NET framework. Microsoft, when they split off the .NET Core from the .NET framework, their intent was to make it cross-platform. So you can run .NET Core on Windows, Linux, Mac OS, Docker, you name it, you could probably run it on there. In our particular case, we're actually going to be running it on Linux. However, they don't allow you to do the development over there. They don't have an SDK available that runs on the ARM architecture yet that I'm aware of, unless they've announced one recently that I haven't picked up on yet. But in the case of the .NET framework, you're still restricted to the Windows ecosystem. So Windows 10, Windows Server, Microsoft Azure, you're stuck in Microsoft's world. .NET Core, however, you could pretty much run it on anywhere you really want to. They have this nice thing where you can do what's called a self-contained application, which bundles all of the runtime libraries necessary to run your application with your binaries, and so that way you just copy a folder over and execute. My preferred means of working with .NET Core is actually through PowerShell. So let's go ahead and do... Yes, Dave?
My understanding of the original .NET was that it's a runtime platform that accommodates like all kinds of different languages, right?
Well, in the .NET, in .NET in general, you more or less, you have a handful of languages you're really going to be looking at. You're either going to be looking at C# or Visual Basic is the two most popular.
Mm-hmm.
There's F#. There's also Visual C++ that you can use. And you can also throw Iron Python into that list as well, which is the ability to use the .NET framework from Python.
Well, my question was then, does the .NET Core that you're pulling down, does that also support that same number of languages?
At the moment, .NET Core, I believe, I know for a fact I've played with F#, C#, and I know Visual Basic is available.
Mm-hmm.
I believe you can do C++ with it. I have never actually attempted that, so I'm not 100% certain. But I know F# is Microsoft's attempt at a functional language as opposed to object-oriented.
Mm-hmm.
But C# and Visual Basic, pretty much, if you see the words .NET, you can assume C# and Visual Basic are going to be available. At least for now, until Microsoft finally gives up on Visual Basic, which I wish they would. But that's
I found a Pascal.NET from people out of Russia.
that does not surprise me.
Works.
Yeah.
Now I heard you say C or C++ in reference to .NET Core, but not .NET, or did you just miss that one?
No, I mentioned C++ in the realm of .NET.
Okay.
Now, one thing to keep in mind, .NET Core 2.2 is the current version of .NET Core that is currently released. 3.0 is due to be released at the .NET conference at the end of next month, which is September 23rd, 24th, and 25th. And that's when 3.0 is supposed to be released. As to if they actually release it at the conference or not, that, let's wait and see at the conference.
All right.
.NET 3.0 does give us a lot of really cool new features, but I believe, if I remember the announcement correctly, 3.0 or 3.1 will be the last of the .NET Core releases. And then 4.8 or 4.9 will be the last of the .NET Framework releases, because in the end of next year, so around November 2020, Microsoft is supposed to be merging the two .NET frameworks together and just simply calling it .NET 5.
That will incorporate the parent .NET and .NET Core.
Right, it's supposed to be backward compatible down both branches.
All right.
And then that's going to be the new standard going forward. And they, if I remember the timeline correctly, it's like every 2 years, it's the new .NET 6, .NET 7, .NET 8.
All right.
That's the timeline that I remember. I could be wrong. In fact, I am frequently wrong. So before you quote me on it, go look it up.
They'll get rid of the 4 dots and stuff. They'll call it like least candidate or something like that.
Well, that's why it's 2 years in between.
That's why they won't go to like 8.0, 9.0. It's just like this release candidate in 1902 or something like that. 2020.
All right, so let's make a nice directory. We're going to call it PieDemo. Let's go into that demo. And the .NET command, once you have your .NET 2.2 framework SDK installed, if you look over here, there's the core runtime, which you don't actually have to have the runtime installed if you do a self-contained application. If you want to be able to build them, you do have to do the core SDK, which in my particular case, I actually have both Visual Studio and Visual Studio Code installed locally in my machine. And through the Visual Studio installation, I was able to install .NET Core 2.2 with Visual Studio. Now, to get everything set up, the easiest route I have found is just use .NET, which is the .NET Core command line reference, which you probably can't. Oh, it's not going to let me zoom. Go figure. Properties. There it is. And fonts. There we go. I'm hoping everybody can read that now. But the .NET command is what we're going to look for. New is symbolizing that we're going to be making a new application. And now we need to give it an application template that we want to use. So let's do console, and then hit enter. And what this is going to do is it's going to go, see, it found template console application was successfully created. And it looked at the directory we were in and named our CSproj file after the directory we were in. Because I named the demo, I called it PieDemo, so now we have PieDemo.csproj. Since I have Visual Studio Code installed, I can also do code dot and hey look, now here's Visual Studio Code. It's about to give me an error message for particle stuff. Close that.
Darren, I know if I go to the package manager, I see both .NET Core and I see Mono.
Yes.
Was Mono like an early?
Mono originally, my understanding of what Mono was, is that originally it was an attempt at reverse engineering the .NET framework and allowing it to run on platforms other than Windows, which you can't actually run Mono on Windows. But the Mono was actually pulled into .NET Core.
Oh, okay.
So with .NET Core, the need for Nano is less, but the folks at Microsoft are actually using what the guys at Nano had helped build. So I don't know if you guys saw that just now, but I had an alert that popped up down here in the corner. And it says, required assets to build and debug are missing for PieDemo. Do you want to add this? And what it's saying is I don't have the C# extension yet. So I'm going to go ahead and hit yes. Local compilation and CLI commands will not work. Okay, well, we're not going to do that from inside Visual Studio Code anyway. Okay, so if we look here, we get a really simple skeleton app that just says hello world. If I go over here to PowerShell, I can do .NET run. And look, it says hello world now. But I can also do this, .NET publish -R, and we're going to symbolize what our runtime is here. And excuse me, Microsoft has documentation of what all the supported runtimes they have. They're called RIDs. One common one is either going to be Win-x64, Win-x86, if you want to do a generic Windows for a specific 32-bit or 64-bit operating system. In our case, we're going to use Linux-ARM.
You missed an L.
No, I didn't.
Oh,
Here, let's do that.
there it is.
All right. Now, if we open up a Windows Explorer, we can see here we have this nice bin directory. Inside bin, we have our debug, because we're currently in debug mode. This is going to say .NET Core App 3.0 because 3.0, I currently have the preview for 3.0 installed, and the .NET keyword automatically defaults to the highest version you have installed. But for what we're doing, the code is actually no different between 2.2 and 3.0. And we have this nice Linux-ARM folder here. You'll see that there's a DLL created here, an executable, a debugs file, as well as a deps file for our assembly. If we go into Linux-ARM, you'll see that there's a bunch of extra files that have been dumped here, including PieDemo that's just a file. The only reason why Windows recognizes that as just a file is because that's a Linux executable. I believe if we go in here to publish, yeah, and here actually contains everything. So if I come over here to my my Raspberry Pi session, over here with MOBA XTerm, when I open it up at an SSH session, it automatically opens an SFTP session for me as well, using the same credentials that I used to log in for SSH. And I could actually have this nice little checkbox down here, which you can't really see, but I did check it. If I come over here and do make directory PieDemo, and then cd into PieDemo, it'll change over here, over on the this side, to show that I've moved directories. Now, let's see. I can upload to current folder, but let's go up a directory. Oops. All right, this is in my source folder. Come here, source folder, repos, and I made this nice, where'd it go? PieDemo. All right, let's go into our bin. These are all the folders you just watched me navigate through. And we come over here. Now we do have to actually select all. We do need all of the files to come with us. And there's actually quite a few of them. 191 of them to be exact. With .NET 3.0, they give us the ability to actually merge all those into a single file, so we only have to copy one file over. But for the sake of this demo and using the most recent version that is fully released, I'm not going to actually utilize that particular functionality, mostly because there's a handful of gotchas that go with it that I haven't quite worked out for myself yet. But if you notice, SFTP like this is actually fairly quick. We're up to 108 out of 191 files. Once this is done, I could actually, basically the entire point of my presentation will be complete, except I won't, a Raspberry Pi presentation about just running software on it is not nearly as exciting. So I will actually interface with an LED and show how to blink that LED from the .NET code. I mean, otherwise, now that we have the code actually copied to the Pi, we need to make the executable file actually executable. I just use chmod 777 because I like living dangerously. And then sudo.
What did that do, chmod?
That gave the PieDemo pretty much all permissions. That's the blanket, basically allows it to run as root if it needs to. I'm going to run a sudo demo, sudo PieDemo, and of course it's not there because I forgot to put the // in front of it. And hey, look, it says hello world. Congratulations, we've now run a .NET Core application on a Raspberry Pi. Thank you, good night. But that's not nearly as entertaining. Let's go back over to my PowerShell here, and let's do PieASP demo. Oops. mkdir. All right, so I made this new demo. We're going to call it PieASP demo. Let's cd into it. And this time I'm going to use the template called Web API. This one is a little more complex. There's going to be a bit more code that's going to go with it. Let's go ahead and go look at that code. This one is actually a full-fledged, oh yes I know, a full-fledged web application running in the ASP.NET Core app stack. So we have this nice weather forecasts data model. We have our program.cs, which should actually look fairly familiar to the Hello World application we just looked at. This is just slightly more complicated in the sense that we're actually creating a host application. So we're creating a sub-process to run the ASP.NET Core runtimes underneath it. So basically, this is just a bootstrapping in order to get us into the ASP frameworks. We have our startup.cs file, which this is actually configuring everything for our framework. And the one thing I haven't touched yet is we have this csproj file. And this is where all of the settings for your project end up. In this case, it's telling, we can see that we're running a .NET Core app 3.0. I can actually change that to 2.2, and this application won't run because of the template. The template is explicitly porting to 3.0, but if I had done this with 2.2, the 2.2 would have worked just fine. And there's a lot of other settings in here, like one of the ones that I like to do. Actually, I don't have the IntelliSense here, so. But one of the ones I like to do is treat warned as error, which treats code warnings that the compiler and the IDEs will generate. It treats them as error messages. So you can't actually compile as long as you have those warnings. And that's just a means of making sure that I have cleaner code. But we also have this app settings.json file. Anybody who's ever worked with ASP.NET from the old .NET framework side of things, this is actually the replacement for the web.config file. Settings that you previously would have had in web.config, now you'll either configure them with startup.cs or you'll put them over here in this app settings.json file. However, the things that go in the app settings.json file, for the most part, won't actually be read into the application unless you explicitly tell them to. And for our particular purposes, I don't have anything I actually need to put in the app settings file here. But the next important bit is this folder called controllers. Anybody who's familiar with ASP.NET MVC will know that this is the controller part of the model view controller aspect. And so what this gives us is we have this nice, this gives us our REST API endpoint. So if I go back over here to PowerShell and do, excuse me, Darren. Is there an excuse for you?
What?
I said, is there an excuse for you?
No.
If we do .NET Run, This one, it actually also auto configures for HTTPS. But I'm actually not 100% certain what it's doing in terms of SSL certificates. I do know when you're running with IIS Express in Visual Studio, it does give you a sample certificate that you then install in your cert manager to allow you to run HTTPS and still get the green lock icon for everything and not get error messages. But that is not recommended for production use at all in the least bit. This is taking its sweet time. Actually, it looks like it is running already. So, localhost 5001. Oops, 5001. And this should actually probably give us an error message. Yep, empty response. So if we flip back over here, let's see, our endpoint is controller name. And our default get is going to give us some random information about the weather. Okay. Going into the routing aspect of ASP.NET MVC is not in the scope of what I'm talking about tonight, but go into weather forecast. Why did that not give me
Get.
what I need?
Do we have to?
Yeah, I might need the /get. Nope. I also may have spelled forecast wrong. See, by default, it should actually be triggering a get command. Okay, well, it's not going to give us on 5001. Let's try 5000. Yep, there we go. Oh, it redirected us to 5001, but didn't work the first time. Okay. Thank you for being confusing, Microsoft. I really appreciate it. But if you notice, it gave us it spit out a bunch of random data because it's actually not looking up the weather in this case. But you can see the data is in a JSON format. If I wanted to, I could actually go out and grab a runtime library called Swagger. Actually, I think it's called Swashbuckle in the case of ASP.NET, the NuGet packages, and we could actually have this in a nice, pretty interface that'll let us test it.
You can go to like a pretty JSON website,
Oh yeah,
do the same thing.
Extension, JSONify, I think.
yeah. There's lots of different options that I could go with. And here in a little bit, I'll flip over to an application I'm actively developing on as a home project that is actually using the Swagger that I mentioned. But this is just demoing that it is actually giving us information. All right. Yep, and then this is actually giving us the output from the Raspberry Pi, or actually no, this isn't running on the Pi yet. This is running on my local machine. So if I Control C, there we go. It shuts down the application. I can then do that same .NET publish -r Linux -arm. However, there is one. Actually, no. Let's just keep going with this for a second. Let's. Are you going to catch up with me? Apparently not. Okay. Let's go ahead and upload all those files we had from a second ago. Oops. Hi, ASP demo, bin, debug, .NET Linux ARM, publish, Control A, and let's open them. And this one actually has significantly more files. We're up to 323 files. And that's because this is actually also containing not only the .NET Core runtime required libraries, but the ASP.NET Core libraries as well. There is one additional configuration that I actually was completely slipped my mind when I was planning this particular demo, and that's we actually need to install and configure a reverse proxy, because by default, ASP.NET running as a self-contained app runs its own internal web server called Kestrel, but Kestrel only responds to HTTP calls over localhost. So if we wanted to hit it from outside my Raspberry Pi, I would have to hit it via a reverse proxy. Typically, I would use Nginx to do that, but setting up and configuring Nginx is actually something I don't have my documentation for right in front of me, and I'm pretty sure you guys don't want to watch me searching through Google for the documentation, because that can get boring. Dave, you had a question?
Could you briefly explain the concept of reverse proxy?
What a reverse proxy is, it allows you to run like in the case of Kestrel, it's running locally and only responds to calls over localhost. Nginx essentially runs as a reverse proxy. It gives us the ability to call and hit and have an external facing interface that then translates into a localhost call on the local machine. And that also gives us the ability to do additional filtering and handle our SSL and things like that outside of our application, as opposed to having to have it internal to our application. And it also allows us to give us more fine-tuned command and control over our network access and things like that. Because also you never know, the other good thing, another good use case for reverse proxy is if you're running as a Docker cluster. So you have a reverse proxy on an external node that has an external facing network connection, and it will internally route that to whatever the internal Docker node that is the current one that's going to serve this particular call into your web application. Okay, just like I did before, chmod
Thank you.
7 PieASP demo, and then sudo PieASP demo. And we should see a lot of the same output we just saw from a second ago. If I come over here, let's open a new session. SSH. Pets 192.168.43.199. Go away. Localhost, come on, 5,000 / weather forecast. And hey, look, there's that exact same data we just looked at on my Windows machine, on the Windows browser. And if we flip over here to this other terminal, oh, it failed to determine my HTTPS port for redirect. So it's only running in HTTP mode right now. But if you can see, it actually did respond with my call. So we have a full-fledged ASP.NET web application running in Raspbian on a Raspberry Pi.
Awesome.
And you didn't need the reverse proxy because you're running on that machine itself. Once you get to
Correct.
your laptop, you will.
If I wanted to hit that from the browser on my laptop, I would have needed that reverse proxy. But here, I just use curl, so that way I could hit it from the local machine. Since I'm running headless, I don't have a browser on the machine. Otherwise, I could have actually hit it from the browser running on the Raspberry Pi. Now, let's flip back over to our previous demo with Hello World.
Quick question on that Raspberry Pi with running
Okay.
the web, is it running as local host?
Yes.
And you said you were using curl to redirect it, right? Or to get
Well, I
to
used
it.
curl to hit localhost.
Hit local host, because,
But it's running against port 5000.
okay, localhost on that, on your machine on that is 127.0.0.1, right? I was
Right.
wondering, that's not routable, right? So you have to have a real address if you wanted to host something on the Raspberry Pi. So I'm just wondering.
Right, so it's actually listening on localhost. I believe,
Because if you're looking at localhost on your machine, you're looking at on localhost on your machine.
On my
there,
laptop,
on the
right.
laptop 5000, not the localhost that's on that Raspberry Pi, unless you're running the browser and the GUI interface.
right, and so like right now, if I were to hit that localhost 5000 again, it'll actually tell me that it can't find it
Yeah.
because the application is currently not running on my machine.
Okay.
It's running on the Raspberry Pi currently.
Okay.
But this is a library that I really, really like. Oh, what just happened? This is called Raspberry IO by the folks at Uno Square. I'm not really sure where Uno Square is. I think they're in Guadalajara, but I'm not 100% certain on that. But this is a really, really cool library for accessing the GPIO pins on a Raspberry Pi.
Is that just in .NET?
This is written for .NET Core or for
Yeah.
.NET Nano or for Mono.
All right.
And to me, this is a nice alternative to being forced to run the Python libraries that almost anybody and everybody else has published so many different variations of. And they've actually recently, with one of the more recent changes, if you see, they actually have a breaking change listed here, made it so that you can actually use whatever back-end GPIO engine you want to use. They've actually used, I forget what the name of the engine they've been using, Wiring Pi. They've used the Wiring Pi library under the hood in order to actually facilitate the true connection to the GPIO and just created a .NET wrapper around it. But now they've given us the ability to where if we wanted to use a different library, we can just generate a new wrapper and plug it in, and they gave us all the interfaces we need to just plug in and use whatever underscored library we need. A side effect of that is when you reference the GPIO pins from your code, it references them by their BCM number, so their Broadcom pin number. A really, really excellent website to use is pinout.xyz. Anybody who needs to reference the GPIO pins on a Raspberry Pi, this is probably one of the best resources you could possibly find because it tells you what each pin is. It also gives you the alternate configurations for those pins. In our particular case, we're going to be looking at pin number 23.
I keep a browser tab pinned with one of those in it.
Yeah, so pin number 20, physical pin number 23 is also Broadcom pin number 11, which is also one of the clock pins. And here's all the alternate. And remember those device tree overlays that I mentioned earlier for alternate configurations for the board? That is actually one of the ways you can change what each of these pins actually do. Yes, Dave?
So as far as numbering of the pins, there's only two schemes, right? There's the physical pin number, and then there's the BCM number.
There's actually a third scheme if you're using Wiring Pi.
Yes.
Wiring Pi has its own numbers, so in this particular case, you can see all three of them listed here. Physical pin is number 23, so that's the pin you can see. If you count, 1, 2, 3, 4, 5, you'll get the 23 eventually, and that's the pin they're referring to here.
Yeah.
According to Broadcom, the pin that as it maps to for the processor is pin number 11.
I was going to say 8.
And then Wiring Pi, the underlying library that the Raspberry IO uses, is actually pin 14. As to why Wiring Pi has its own pin names or pin numbering, I really don't know. But
I think they changed the number of headers and stuff like that. It came from 23 or something like that. Now it's
yeah,
like 40.
the original one stops.
Original ones were like
stopped
Small.
around like this point, this
Yeah.
area.
So that's why
I
they
think it
have
was
their own.
28. But even still, like these pins didn't change between the variations of the Pi.
Yeah.
So even the Pis that have the smaller GPIO pin out, these pins are still identical going backwards. So they did maintain that backward compatibility.
So-
Speaking of backward compatibility, one thing that I do need to mention that I forgot to call out earlier on, .NET Core, the Linux runtime requires an ARM v7 processor or newer, which that means that the Pi 0 and anything older than a Pi 2 cannot run the .NET Core runtime. You can compile it, you can copy it, you can try all day long, it'll just give you really weird error messages. I've seen the error messages, I actually don't remember specifically what they were, but your application won't run and you'll be frustrated for hours.
You said the 0 won't run also?
0 won't run it because the 0 is actually running the same processor that I believe the Pi 1 was running. So basically, if your Raspberry Pi can run Windows IoT, you can run .NET on it. So that's the Pi 2, the Pi 2B, the Pi 2, the Pi 3, Pi 3B Plus, and Pi 4. So any of the B model Pis, but this also includes the A models that are newer than that as well. Because they use the same processors and the same images, they're just a different layout to the board.
You know, one thing I just noticed on like a lot of Arduino boards and ESP32 boards, those actually have pins that are labeled GPIO. The Raspberry Pi doesn't have any pins that are labeled GPIO, like GPIO 7, GPIO 5.
Right, and that's because they're BCM 11, BCM. With the Arduinos, you're dealing with microcontrollers and hardware that they have almost complete control over.
Mm-hmm.
With the Raspberry Pi, they're connecting to an actual processor architecture, which is a lot more complicated, a lot higher level of computing than what the Arduinos are typically capable of. Now, with the newer Arduinos, specifically the Maker series or the MKR series, they're now using ARM Cortex processors. They're Cortex M0s, which makes them more processors instead of microcontrollers. And so they're capable of more, but they're still using the Arduino runtime on the chip. But that's just a matter of swapping out how you're compiling the code into the machine level language that's running on the device.
Sure.
Okay, so installation here, it says to use install package. Well, this only works if you're inside the package manager context. So we're going to go ahead and install Raspberry Pi IO. But what we're going to do instead is we're installing it from the command line without the package manager. So let's go back over to our Pi demo. And so we can do .NET package install, and then what's the name of our package? Uno Square.Raspberry.io.
Can you use NuGet from the command line? Or is that a built-in Visual Studio kind of thing?
You can actually, but
I was just wondering.
I seem to be missing. Add package. There we go. That's what I was missing.
What is the package installer? Is it? part
This
of the
is actually
.NET
a
command?
wrapper around NuGet.
All right.
Oh, okay.
Okay, so .NET add package. See api.nuget.org.
So is that like NPM?
It's basically it's NPM except with specifically for .NET
Mm-hmm.
components. Now, there are NuGet packages for things like Bootstrap and jQuery and things like that, but Microsoft has steered people away from doing that in favor of using NPM, Bower, etc. All right, so if we come back over here, well, actually, let's use this one as an example real quick. If we remember our CSproj file, there's not a whole lot to it. Our PieDemo one looked identical to this. This is the ASP.NET one. But our PieDemo one looked identical to that from the start. But now, actually it had this extra line telling it was an executable as opposed to a web app, but whatever. We have this extra item group that is a package reference. And this is this is pretty much identical to if you're running in like Angular or whatnot, your packages.json file. So you list out you list out what packages you want included and what version of that package you want to include. And as part of that add package command, it automatically added it here, and then went out to NuGet and downloaded the package and went ahead and put it into the correct directories we need to run it, which in our case is this debug, or this object directory. There's like, eventually we'll find it in there, but I don't really want to dig for it. I'm pretty sure you guys don't want to watch me dig for this. Now, if I remember correctly, we do actually have to add this other provider. Okay. And now, what this gives us the ability to do sorry.
Yeah, are you watching the time?
Yep, we have 20 minutes left.
All right.
We have this nice example they have in their code, which they're using GPIO pin number 17. We will actually be using pin number 23. And so let's go ahead and copy that. Let's come over here to our PieDemo file. And let's go ahead and get rid of hello world. And let's just paste that in there real quick. Just to make this actually easy for me, because I have not done this in Visual Studio Code in a while, I'm going to flip over to actual Visual Studio. Now, this is the Visual Studio Community Edition, so this is also free. So you don't actually have to use Visual Studio Code if you don't want to. Visual Studio Code, however, does run in all the same places .NET Core runs. So you can do Visual Studio Code from Linux, from Mac OS, from Windows. You can't run Visual Studio Code on a Raspberry Pi yet.
VS Code rocks. I got it on my Linux box and my MacBook. I use it for, man, C, C++, JavaScript.
Okay. I just happen to prefer the interface for Visual Studio just because, and in my regular day job, I do work with .NET Core at work as well. Our entire application stack is built around .NET Core, MongoDB, and an Angular front end. But because we are an official, I don't know if we're a Microsoft partner or not, but we all have actual Visual Studio subscriptions. All right, one of the things I really like about running in Visual Studio over Visual Studio Code is I remember the keyboard shortcuts for cleaning up my code. It also gives me this nice shortcut that I can do, hey look, using, and it automatically populates my, go away.
Are those phantom squigglies there?
It's telling me that I am missing using statements.
Mm.
Okay, however, I can run this on my local machine. Oops. I tried to create a solution file. I don't want a solution file for this just yet. I can run this on my local machine, but it's not going to actually run correctly because we have dependencies that don't exist in Windows that the libraries are going to be looking for. But I can, however, still flip back over here and do .NET publish -r Linux-ARM. All right, and let's go back over here. Let's go to PyDemo. Actually, let's go ahead and upload files. Which unfortunately, I keep forgetting to use the -o that actually gives me a output command, and I can put a path into the output, so I can have the output, instead of going into this big long directory tree, have it go to wherever I want on my disk. So here I have it updating all the files here. If you notice, there's a few new files that says 196 instead of 191. Oh, and I forgot to change my PIN number.
The longer side of the LED is the anode positive,
Okay.
if you wanted to recheck it.
Well, since I forgot to change this from pin 17, let's go look up what pin 17 is real quick. BCM pin 17 is pin 11. Okay. So let's flip this. Oh. Put it there. And let's see if this works real quick. Alright, files appear to be copied. /demo.
Why are you running in sudo?
Oh, I was afraid of this. Okay. In this particular case, I have to run a sudo because I need to give it the elevated permissions to be able to access the GPIO from the user space.
Okay, yeah.
Okay. Let me.
And is that C#?
Yes. So far, we've been doing all the code that we've been writing has been in C#. Where did that example go? They have an example of the PieBaker. And I apologize for. There we go. Not being as prepared about this as I could have been. There we go. Okay. So do this part one more time. This is the part that I really don't care for running .NET Core on the Raspberry Pi, is because getting the debugger to connect across is actually harder than it should be. But part of that is because they call it off-road debugging. And it's a topic I've been meaning to actually look into, but I haven't had a chance to actually dig deep into it yet. If I come back over here, let's go ahead and, since we were already in that directory, and open. All right, so while that's doing that, I'm going to go ahead and hook up the LED to the Raspberry Pi, and I'm doing something I know I should not do, which is hook up something to a Raspberry Pi GPO while the Raspberry Pi is running.
Do as I say, not as I do.
Yeah, pretty much. Luckily, though, I'm connecting to all the pins simultaneously, so there's no risk of me actually crossing the pins. All right, so here in a second, once this is done copying, which we're up to 113, so not too terribly bad. this still compiles a whole lot faster than most .NET applications I have ever had the mispleasure of dealing with in my professional sense. All right.
There it is.
Hey, look, we got a blinking LED on a Raspberry Pi running in .NET Core, written in C#. Ta-da!
Live at the Capitol Factory.
Yeah,
Make it blink again.
Did a video day. Show everybody.
Oh, wait.
Oh.
It's gonna stop blinking just as soon as you get the camera over to it.
And there we go.
Yeah, there you go. Do it again.
Hey, we gotta zoom in for a hyper close up here. There it is.
I was going to actually do this exact same code from the ASP.NET side of things. However, we are running just a tad short on time, so rather than do that, let's go ahead and open the floor to questions. Not that people haven't been already asking questions as I've been presenting.
So I guess you had a controller on your Pi in your home project, and you're calling into it. What are you doing?
Right. For my home project, what I'm, which actually, let me just go ahead and, my central server for my home project actually is not a Raspberry Pi, even though it could be. I'm actually running a headless Ubuntu server. And so right now this is, I have it as a private repository because I was dotting my T's and crossing my I's with work to make sure that I don't have a conflict of interest between what I'm publishing at work and what I'm publishing for home. I don't think I actually have a conflict anymore because I have completely re-architected what I'm doing at home. So here shortly I will be opening this up as a public repository so anybody can go take a look. But what this is, for my home project, what I'm doing is it's, as you could probably tell from the name, it's a home automation project. And so what I am actually doing is I have a .NET Core web application running, it's a web API, so it's a REST implementation on a Ubuntu headless server that is connected to my wireless network. I actually have it hooked up hardwired at the moment, but my server has a secondary NIC on it that I am keeping isolated from my main network, and all of my automation devices will actually be on that separate network, using this server as a bridge to bridge the two networks together. So any client on my regular main network will not be able to directly connect to any of the automation devices without first going through this server box. So that way I have a nice barrier to entry. And the server box is also operating as DNS, DHCP, time server, the whole 9 yards for the separated network. But it's operating as a DNS client on the main network. I did set it up with a static IP address on my main network, but that's anybody who wanted to implement this project for themselves, how they do their networking is entirely up to them. But what I'm actually using here is the automation API, which actually, let's go open it from the Visual Studio aspect, because I actually have all this code local. Come on. But the API is, I've actually taken a really neat approach. Because I'm using .NET Core 3.0, I'm using one of the new features 3.0 gives us, which is the ability to do it's this assembly dependency resolver, which allows us to actually load assemblies into our application more easily. We've been able to do this with .NET Core and the .NET Framework for a very, very long time, but it's always been cumbersome, it's always been difficult, and most people don't even talk about it because it's that difficult. But with Assembly Dependency Resolver, it's actually made it incredibly simple. So now, I have this automation API application that I can just go ahead and run this, And I'll be able to show you that Swagger interface that I was mentioning before. But if you look in this controllers folder while this is spinning up, if you look inside this controllers folder, you see a rooms controller. Oops. Go back. There's a rooms controller and a weather forecast controller, and that's it. Come over here. Nope, not that one. This one.
Are you basing any of this off of Apple HomeKit at all?
No. Oh, it didn't show up this time. Okay. I have something missing from my configuration, but I have another project in my set here called PowerStrip plugin, which this just compiles out to a class library, and then I copy that class library into the automation project. I have a plugins directory in the output that I just drop the DLL into there, and it automatically picks it up when the application starts, and I can see anything that's in it right here from Swagger. The idea here is that all of the different devices that are going to be operating as the home network, the main application doesn't have to know about devices that don't exist. And also, I don't plan on making all the devices myself. But I still need to interface with devices, even whether they exist or whether I've made them or somebody else has made them. I still need to interface with them. But I don't want to have to write all those interfaces either. So what this gives me the ability to do is give people a set of default interfaces and say, hey, implement this, and you'll be able to just drop your DLL into the plugins directory, and everything will be up and running. So drop it in, restart the app, you're good to go.
You might want to take a look at Apple HomeKit.
You are not the first person to have told me that.
All right.
However, I have to be careful how much of Apple HomeKit I look at, because I have not signed an Apple non-disclosure agreement.
Yeah.
Also, actually, I have signed one, but it's been close to a decade since I signed it, which means it's no longer actually in effect.
Go look at the Apple ESP HomeKit SDK. There's a non-proprietary version of that.
Yeah. Now, without having looked at that, because I actually haven't looked at any of the Apple HomeKit stuff at all yet, one of the things that I am planning on implementing with this, and I only bring this up because this was mentioned because of somebody else, and I actually already had this thought before it was mentioned. But one of the interfaces I'm planning on exposing is an interface that tells me what services the device itself supplies, and I'll have a handful of ready-made service interfaces that you'll have to pick from in order to do. Which, from my understanding with my talking to the individual the other night, that's fairly close on to what Apple HomeKit is doing.
Yeah.
Yeah. But I'm doing it my own way, and I'm not looking at Apple HomeKit because
And you're not
it's
doing it. You're duplicating the functionality, but you're not anywhere near the Apple universe. You're doing
nowhere near. The closest thing to the Apple universe that this project has is the fact that my wife will be interfacing with this through an iPad.
Yeah.
That's it. But one of the other really cool things that I have here is this application right here. I can't currently run it because I'm in the process of rewriting it the other night. I broke it, and I haven't had a chance to fix it yet. But this is a full-fledged MQTT server. Utilizing an MQTT library, if I go to dependencies here, I can go to packages, and MQTT net, and MQTT net ASP.NET Core. I'm using those two libraries, and that's giving me the low-level MQTT functionality. But I've added my own wrapper around it, so I can actually execute it as a Linux daemon, which is a self-healing daemon. It'll automatically restart itself in the event of a failure, which is really cool and something I'm still trying to wrap my mind around in terms of .NET, because anybody who's messed with any .NET application for any length of time knows that as soon as you have an uncaught exception, you're dead. You have to manually retrigger your application or configure an external party that will automatically watch for your application's health and restart it in the event of its failure. Like PCF, for instance, Pivotal Cloud Foundry. You can set up a watcher that will watch an ASP.NET application running inside of it to automatically just ping it for health. And as soon as it no longer gets a ping, it just recycles that container and spins up a new one and starts the application over again. But in this particular case, the application itself detects when it quit running and starts its child process over again. However, if the main application runs into an uncaught exception, you do still die. So keep that part minimal.
Can you not put a generic exception handler in the app?
You can. In fact, most people do in order to prevent this exact scenario. But I'm still early enough on in the development of this that I haven't put that exception handler in there, mostly because I want to see these exceptions. Because the more exceptions I see as I'm running, the more exceptions I can actually explicitly code to avoid.
Gotcha.
And I do actually follow a TDD mindset with this. So if you notice, there are actually four tests over here. Right now, not everything actually has tests for it because I was doing a lot of wild figuring things out, and things were breaking everywhere because I changed frameworks mid-stride. And yeah, it's a bit chaotic at the moment. The web application does at least run. It gives me my rooms controller, and that's ultimately how I'm separating everything. Is I have a room, and a room contains devices. So my rooms will be the entry point for all of my devices. I know this is actually kind of contrary to like how there's a Has.io, which is an existing open source home automation system. I believe it's written in Python. They're actually using a person-centric approach to it. So not really sure how that really works because I haven't dug deep into that. But I didn't care for the fact that the platform was written in Python. I don't have anything against Python, it's just not my flavor of language. And since I use .NET daily at work anyway, I'm fairly fluent in it. At least I hope so. But in terms of this project, does anybody have any more specific questions, or did I kind of ramble on for too long about it?
Well, let's look at your controller, your room controller.
Oh, my room controller? Oh, I'm also following a service and repository pattern. So if we look at my room controller right now, it literally just has a get all command. And anybody who's actually fluent in how tasking works in .NET should notice that value task is something new. This was introduced with .NET Core 2.2, and this actually allows the framework at runtime to determine if an asynchronous call is actually going to execute asynchronously versus synchronously, because you will sometimes run into situations where an asynchronous call can actually execute faster if it just executes synchronously because the return is just going to happen. And the framework has almost enough information to be able to guess that at runtime. And so this is a micro optimization on the memory stack, because every time you run an asynchronous command, it adds stacks to your, it adds frames to your stack and adds components to your heap for your memory allocations, which ultimately, if you're worried about your memory, those are the two things that you're watching. In this particular case, if it decides to run something synchronously, it doesn't have to create that overhead and you get a micro memory optimization. Most people, shouldn't even need to use this, but I figured it's an easy enough thing to swap out. It's literally a one-to-one replacement with a simple task keyword. This is just a struct that wraps around task, and it's a one-to-one replacement. Other than that, everything is identical. Also, it is now 9 o'clock. So, any other questions, comments, volunteers to help me with this? If anybody's interested, I do actually have my business cards with Austin IoT sitting right up here on the table. Feel free to take a couple. I have a whole other box at home. Thanks, Dave.
You're welcome. When you need more,
Yeah,
let me
very,
know.
Very informative, thanks for that.
You're
For
welcome.
for following the project.
All right. Well,
All right.
thank you.